Okay, welcome, people of Earth, to day 20 of Advent of Code. Um, I, I have 3 minutes before the puzzles open, so I might as well look back on yesterday, although I don't have very much to say. Mainly, it took me a long time to kind of understand the problem yesterday, and I could argue that like the problem description wasn't totally clear and there were a couple of confusing things in there, but in reality, understanding specs that are only clear in hindsight is a surprisingly large amount of being an engineer. so so it's fine, and I mean, I don't think it was a terribly unclear problem description, but a few words here and there I think would have made a bit of a difference. But again, those are kind of nits that I'm picking. And writing a clear spec is incredibly hard, particularly for like a problem. The whole point is that you don't want to tell people exactly how to get from here to there, right? So given those handcuffs, I think Eric does a fabulous job with all this stuff. So, anyway, um, and as I predicted from the very beginning, the hardest thing for me yesterday was writing this silly little rotation function. I mean, I had to rewrite it like 2 or 3 times, and even the final version I got is wrong. If you notice, if we say we want to rotate 0 times around an axis, we rotate once. But luckily, if we say we want to rotate 3 times, we rotate 4 times, which is the same as rotating 0 times. And for the way that this function is used, that's all good enough. So, yeah. And I assume if we really wanted to, because we do what 4 times 4 times 4 is 64 different rotations. But in fact, there are multiple ways to rotate them all. You can rotate along multiple axes in combinations that will get you the same result. So there are actually only 24 real rotations, and the only thing we do is we iterate across all these rotations that we just build by brute force here. It isn't terribly hard to come up with just the 24 that are relevant. But again, a factor of 3 is not a big deal. I mean, similarly, what down here, like we're building sets that are constant and could have been built way outside the loops and everything. Um, if we were worried about speed, these are the kinds of things we would clean up. But it ran fast enough, right? I forget what the time was, but I think 10, 20 seconds it took to run, which is a long time for such a kind of straightforward problem. But still, um, I mean, fixing a couple of these things wouldn't take very long, but like just getting the 24 rotations would take me more than 20 seconds. So why bother? Anyway, let's move on to day 20. Nine bit. Okay. Every infinite out. Wow. Dark pixels. Hmm. Okay, seems relatively straightforward today. Ooh, look at all that. Oh, okay, maybe not so straightforward. Oh, come on. Day 20, right? Okay. Uh, ba 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 ba. What am I doing? 2. Okay, this is all good. Um, no. Do, 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 do. So 999 is yeah, ba 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 ba. Um, for um, what order do we do these things in? Sorry. Okay. 9 pixels. 4. Okay. Up and above. So we do. Um. 4. I'm doing badly. Go faster. Think more. No. Okay. Um. Uh. Um. If. Well, no, what are we doing? Less than. Um. X equals 0. Yes. Um. Okay, so that was that. So, um, um, Okay. Okay, we haven't actually thought through our infinite thing yet. No. Okay. Strings. Okay. And then okay. Yes. Do. Okay. Yes. And then we say grid. Let's add 2 lines at the top and the bottom. Come on. What am I doing? Can we prepend? Does array have prepend? How do you insert at the beginning? This seems like a fundamental operation I should know from memory. Count, accessing, adding, append, insert at, right? Do, 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 do. And can you make a string? And hold on. I'm being slow again, as usual. This shouldn't take so long. What are the... Oh, there are like a million string constructors, though. But is there a repeating? There is a repeating. Good. Okay. This is a lot, actually. Okay. Great. Hey! Sorry. My screen just went blank for a second. So, grid equals new grid. So we haven't done what we need to the first time, though. So, so all this crap, let's grid. That. And then 2. I mean, there's a more elegant code structure for getting this done. Let's see if any of this compiles, shall we? Nope. Okay. What's going on? Let's try that again. What's our error? Yeah. String lines. Oh my god. I'm always so dumb about that. Okay. Not fine. Okay, value. Wait, we got it again? Am I just not seeing what's going on? Why? 7? 7. Oh. Yeah, that makes sense. Okay, what's the next one? Can I find new? Line 15. Here we go. Now let's try it. Okay, we're getting there. For y in 0. Let's actually do this, even though I think it's all going to be the same. Oh, still can't get it. Did we forget 4? Oh. Thank you for catching that. Okay, so what are we actually trying to output here? Is it a visualization or what? How many pixels are lit? Okay, that's implementable. Okay. I actually had written functions to do exactly this, and I've already forgotten the interface. Yeah, let's just to be sure. If x equals well, might as well give it a stab. Nope. Okay. 1, 2, 1, 2, 3. It doesn't really. Should I add more than 2? Is it all wrong? What's going on? I don't know. So let's do and tell me something about that. Well, there's a lot going on right up to the boundary, isn't there? And that is wider. Let's, So let's actually do this. So let's do that again. So that happened, and that happened, and then that happened. Is it wider and longer? And well, considering how much bigger it got, let's I don't entirely trust my math here, but let's go ahead and just be excessive about these boundaries, right? 3, 4, 3, 4, 0, 1, 2, 3, 4, 1, 2, 3, 4, and now what happens? Does it look exactly the same? Looks pretty much. Oh, hang on. No. And this time it's 7668. Well, so I guess we do need quite robust boundaries for this. I don't really understand how that's the case. Wow. What am I doing wrong here? Well, let's start by making sure. And Y and X. Why do I have? There we go. Yeah. I guess we have sample input somewhere, so I guess we should use the darn sample input. But it's getting 7668. Yeah, okay. And we didn't assert. Okay, so we're slow today, and we have a bug somewhere. So let's go ahead and do our sample, for example. No, come on, just you. Ah, I know what it is. I already know what it is. The blank line doesn't show up because of the stupid split routine in Swift. I hate that routine. I just hate it. So now 7740. Now that's definitely the right answer, and we can totally risk being locked out for a long time. Or not. Darn. Okay, so let's data 0, data 1. Well, okay, so what was our plan? We were gonna look at the test data. Right. Oh, that didn't work. Invalid index. And we don't even really have a stack, do we? Yeah. How? Every attempt to debug this in the past. Substring. Test data. One, 0, 1. Enhancement equals. So we got. I don't even. Before we even get to this, so this is actually reading in our stuff. That's crazy. I'm telling you. It's just crazy. So what is our stupid input function? Lines is equals contents of the file test txt split. Oh, that's why, because our out still didn't get anything. What? Hold on. This is all going very badly today. I don't know how stupid I'm being. So this is working. Is it? So we have an array of length 1, 0, and 1 dot, and then the heck? This all looks good. I'm at a loss. What is our input data? Test data is that, so we should have that and then a bunch of short lines. Oh, no. What's going on? And our test data is a long string followed by a long string followed by a long string. Oh, of course. Now we're just being stupid with our test data, aren't we? And how are we doing? Okay, that's what our test data should look like. Oh my. Okay, so we say we have 35. Okay, yeah. So then it should look, therefore, the starting image looks good. Then we do 1, and it looks good. 1, 2, 3, 4, 1, 2, 3, 4, da, 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 da. This all looks good. Second one, da, 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 da. Yeah, and so we get 35 pixels of light. And apply. How many? How many pixels are lit in the resulting image? This all looks good to me. I don't know what we're doing wrong. So, unless our input is also broken, so let's just run this again and then 7740. But that's what we said before. So let's check that our input looks good. Yeah, we have one line. It's all good. I really, So let's just want to check the dimensions on this thing. Um, 108 by 108, so that's, 100 by 100, and then we do our stuff. Um, it says twice, right? So we do it twice. How many pixels are lit in the resulting image? $35 or less. What am I not getting about this? I don't. Well, I'm at a loss. I don't know what I'm doing wrong. Um, uh, 13 by 13, and it started off 9 by 9. Is that what it was? Sorry, 5 by 5. 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. Yeah. 7740. But this is. I mean, hold on. Let's just check that. Oh, hang on. How does that work? The 0 position. So okay. That's the problem. I was assuming the 0 position would be dot, but it's not. So if we invert. Okay, the whole problem is that I was assuming that a blank region would map to a blank region, but it doesn't. A blank region maps to a light region. So let's invert the enhancement, right? So if we make no. So what am I thinking? So if we apply it to everything, the trouble is everything else goes light. So if we were to instead say, what is the inverse of the image? And then invert, how long have we taken? We've already taken 40 minutes on this, and I started out tired. So, so an entirely blank region. So everything beyond the borders actually goes light. So should we just everything beyond the borders, it starts blank, but so new line No, so let's just, instead of all this silly padding, let's start at -4 and go up to grid count +4. What was that? And I think because of ranges, we need to parenthesize all this. Yeah. You might not need to parenthesize this, I don't know. So let's try to think this through. So for all these things, no, and we're no longer doing this because we're computing it on the fly. For if and this is not going to work anymore, so oh no, that will work fine. It's because we're guarding it. Okay, let's and all this. So, first of all, let's run it. Oh, not you. Let's run it on the test data and see if we broke anything. Oh, what a slow day. Oh, new line. 43. Oh, yeah. No, what did we do this time? And of course we don't have a backtrace because we're stupid here. YX. Oh. Yeah, it's square. It's square. Okay, so now what is out? Oh, it's, oh, we did it all wrong, didn't we? Negative, oh. Why is it all pressed up against the left there? Okay, that's what. Jeez, I am just a dumb guy. Come on. Okay, and is that what it looked like here? Yes, those things look pretty similar, and we get to 35. So now, has taken us so long to get here. Now what happens? And it just, what happened? It just stopped. Why did it stop? There we go. Well, that's a different number. Let's put that number into the website and see what happens when we put that number in. How are we still wrong? How are we still wrong? Well, we're still wrong because there can't be infinitely many light things. Look at this border with all these things. That's not right at all. What is the last one in our input? Where is our input here? So the 512th character is blank. So they all turn off. So they all turn on the first time, and they should all turn off the next time. That's okay. Okay. Oh my. Yeah, because the entire grid turns. Okay. If. And. Oh, this is a surprisingly picky problem the example doesn't explain. Oh, no, I need some of that. Yeah. So. Right. Okay. No, let's change it back. Okay, else if t percent okay, so 0 on the 0th iteration, on the first iteration. So this is all very hairy logic, isn't it? So the first one, it starts off. Wait, I'm confused. I am adding blanks at first, but that shouldn't hurt anyone. Then it all goes light, and then it all goes dark, and then we get a completely different number. We have just plugged a lot of numbers into this, and that is not great, because if we're wrong, yeah. Oh, man. Because we're at a 5-minute timeout, so if this is wrong, we're in we're in some trouble. We are in some trouble. Yeah. Come on. 20 seconds. Oh, I would class this as maybe my second or third bad night. In the sense that it's not, well, is it a good problem? I guess it's a good problem, but my own mistakes have made it less fun than it could have been. Because this could have been a 15-minute problem. 20. When I watch the video, I'll know when I could have gotten it if I had realized. I should have checked that the 0th position was a dot, because that's really the key to the whole thing, is realizing whether the 0th position is a dot. So, okay. We got there on part 1. So now what do we want to do it a whole bunch of times? 50 times. So, okay. I don't get why this is fun, doing it 50 times. Really, there's no code changes there. How is that fun? I mean, I'm spitting out 50 grids. And they all are quite slow to spit out, aren't they? Because they're getting big, right? Because I have these rather enormous borders because I'm doing 4 things at the end and blah, 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 blah. So I could have, yeah, there's no need for them to be quite so enormous. I think you only need a border of 2 is the right answer. I mean, even if you're being exhaustive. But let's actually change our code to not print our grid, but instead to tell us which iteration we're done with. Is it still going? So this is very slow. I guess we can also do this to restrict the growth. And, I mean, we could actually make a point of going in and lopping off the irrelevant borders, right? So, yeah. Well, we're only doing it 50 times, so it's not like it's that monstrous. Well, let's forget that. I want to see how much it's slowing down, really. Oh no, we don't need to send it to out anymore. 5, 6, 7. So maybe the code changes are necessary to make it run fast enough. See, but the growth shouldn't be overwhelming, so I don't think it's getting that much. Well, it is getting quite a bit slower, isn't it? So, while we're doing, we might as well write the routines to prune our grid. Prune, and it takes a Okay. We don't need to do this. We're gonna get to 50, aren't we? Before we finish writing this. Um. Uh, which is a fairly big number. Um, oh. How do you count the number that's satisfied? Come on. See, we're going to get to 50 before we get there, aren't we? It is getting really slow, though. 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, 6, 1,000, 7, 1,000, 8, 1,000, 9. So it's going to take another couple of minutes. Okay. Did we get there? We did. So we don't need any more nonsense. I mean, yeah, we've been coding for almost an hour. I'm not really interested in doing, so let me comment out the code that isn't gonna compile, and then we'll just put it in the repo. The point of the function I was just writing is we could just say, for the margin around the edge, if it's all just a band of either light or dark, just erase all that and take the middle that has the information in it. And then our algorithm won't unnecessarily grow the thing, but will only grow the bit that has some kind of information. Oh, well, where did I place on this, actually? Hold on. Leaderboard. Yeah, this is back to my very bad numbers. So, whatever. And the thing is, only 7 minutes between that, and I killed one run when it was fairly close. So, if it only takes, 5 or 6 minutes, and we didn't even run optimized, did we? We should run that optimized. Hold on. Let's just because I'm curious. I'm not going to extend the video so we can figure this out. But I'm curious how fast it runs optimized. Anyway, I'm tired, so I think I'm done for the day. We got to the finish line, which is what Advent of Code is all about. So I will see you tomorrow for day 21 of Advent of Code.